Computers and color theory. A little programming tutorial. My first thought this morning was, explain how programmers make colors with numbers. But then I woke up a little bit more and I thought the idea was ridiculous because it's too abstract to explain in text. And when I finally got out of bed, I snapped my fingers and said, "Challenge accepted!" By the time I returned from the gym, I was grumbling that this is not going to work, at all. But here it is. If you visit editor.p5js.org/catp/sketches and click on Triad Theory, you will see a very simple piece of art in about 50 lines of code or so. You may need to temporarily enable third-party cookies on P5JS. Computers have different functions, or mini-tiny computer programs that can be used to invent colors out of thin air. But we want to focus on just one, the HSL, or hue, saturation, luminosity, sometimes called lightness or brightness, because it is the most friendly function for artists. Hue comes from physics. You see it in a prism. Our eyes pick up colors between red and violet, and that's the whole story. Saturation is how much color there is, and luminosity is the brightness of the color. That is what HSL algorithm aims for, and there is not much more to it. It's just trying to be as useful and as friendly as possible for manipulating color in a very unique way. I guess the best way to use the H, the S, and L is when you already picked a color. If you have a red that is too overwhelming, you lower the saturation. If it is too dark and you need it to stand out a little bit more, you increase the luminosity. HSL is like a tool. It's not a law of the universe. It's just a program written by programmers that helps you adjust the values that artists look for. Just to give you an idea, the most popular color function in the computer world is RGB, where you mix red, green, and blue. Web developers tend to use that a lot. HSL is better for artists because an artist may wish to stay within the luminosity of 80, for example. RGB was not made to use the concept of the fancy luminosity, meaning that switching from red to green will not preserve luminosity at all. There's zero chance of that happening. There's another color function worth mentioning here, and that is the Cmyk. But this function is made for printing, for companies that actually have cyan, magenta, yellow, and black ink in stock, for printing on fabric or paper, for printing out large posters. It is related to the way the printers work more than anything else. In terms of generative art, RGB is a horrible mistake. The HSL gives you colors that hardly ever disappoint, as you can easily reason about brightness and saturation and stay within a simple corridor. But there is more. Because while you reason about brightness and saturation in terms of percents, from 0 to 100, or fractions between 0 and 1, the hue is round. It is a cylinder, a circle. The values go from 0 to 360 degrees. This is another reason why RGB is bad choice for computer art. that function doesn't do circles, and circles are extremely important for art. In color theory, colors that oppose on a circle go really well together. The same goes for a triad, 3 colors, or a tetrad, 4 colors, and 5 colors, and 6 colors, and so on. So if you have a cylinder of colors, and you are looking for a complementary color, or the opposite color, you just add 180 to get it. For a triad of colors, your starting color is the first color, add 120 to get the second, and 240 to get the third one. For 4 colors that go well together, you just go around the cylinder in a 90-degree increments. You are guaranteed to get colors that aren't biting each other, that are in a strange harmony, that look really good together. This is very interesting. In this little program that I have created, I first select a random number between 0 and 360, and that is the main color. Then I add 120 and 240 to get the full triad of colors. And then I create 3 rectangles to fill the screen. I add 2 randomly positioned semi-transparent circles, a big one and a small one, that feature the first and second color. I created the space between shapes by giving them very thick outlines. This is a neat shortcut, not really what outlines are intended for. I did not want to use functions or loops in here to keep the program simple to help with learning programming. Each time the play button is clicked, a new triad is chosen and the circles change position. Right-clicking on the art allows for saving it, and I created the screen width and screen height variables to allow changing the resolution of the generated image, so it is possible to create a desktop background or even something that can be printed out as a poster. I consider this to be an example of how to teach addition, subtraction, division, and degrees. At the end of the class, students would be able to parade some fancy infinite artwork. It is possible to sell such little creations. Something like this makes a perfect background for a poster and saves someone 5 minutes of work. It would probably sell twice a year for $1 or maybe even $5. When I was creating this arrangement, I was imagining 5 or 10 such paintings on the otherwise empty walls of a gallery, at which point one could have a noteworthy photo shoot for an art or design portfolio. Very useful. In closing, color theory is very simple and very useful, and computers do all the calculations as it should be. As always, the infinite canvas of generative art serves as a fun invitation to learn computer programming and fill a gallery.